Hi folks, welcome to the first chemistry vodcast for the year. We're going to talk about scientific measurement tonight. I just want to remind students in particular that they can pause at any point. So we're going to start off talking a little bit about types of scientific observations. And so we're going to sort of start just the general idea here. And the first thing is that there are qualitative observations, which is basically an observation that you make without a measurement. So, if you're observing things and you might note, say, the color or the shape or something like that, that's a qualitative measurement. We can also do a quantitative measurement, which is one that you're taking with a measurement. And basically, the easy way to discern between these two is that quantitative means with numbers, qualitative means without numbers. So if we say the circle is red, that's a qualitative observation. If we say that this circle has a radius of 20 centimeters, that's a quantitative observation. That's a measurement, and basically in science we really want to try to get measurements. Okay, and we can get those in various ways. So maybe we're weighing something on a balance. Maybe we're measuring the length or width of something, like this piece of pie right here. We're measuring the volume of some liquid in a graduated cylinder. And we'll talk a little bit more in the next lesson specifically about that. And perhaps we're measuring something like temperature. Now, all of these things would give us a number, and that's what makes it a quantitative measurement. So the next topic that we want to talk about real briefly is the idea of accuracy and precision. This is really going to be what most of the rest of this lesson is about. These two terms sound like they mean the same thing, and in normal everyday language they do, but in science they mean something specific. So accuracy means how close are you to the actual measurement. Now, what does that actually mean? You're like, okay, what? Okay, I get the definition, but what does that mean? Did you hit the mark? You're shooting baskets. Did the ball go in the basket? You're aiming for a target. Did you hit the target? What happens for us a lot in lab then is, did you hit what the measurement actually should have been? Because a lot of times, particularly in high school labs, we know where it should be. For precision, what precision means is a little something different than accuracy. It's not related to how close you are to the actual measurement, but rather what it means is, are your measurements really close to one another? If your measurements are close to one another, then we would say that your measurements have a certain degree of precision. Both of these things are important in science, and what we're really trying to hit, ideally, is both accuracy and precision. So we're going to do a short little example. This is sort of the classic example of accuracy versus precision. So we got a dartboard, and we're throwing darts at it. So the little yellow arrow here, that's dart number 1. And what are you aiming for in a dartboard? Typically, depends on the game obviously, but typically you're aiming for the bullseye. So first dart hits the bullseye, second dart hits the bullseye, third dart comes in. Hang on a second, let me swing this ankle around. Third dart comes in and it hits the bullseye also. This, in science, is what we'd say this is both accurate and precise. We hit the mark, the bullseye, and all of our measurements, or all of our darts in this case, were really close to each other. That's precision. So if we look at this example, 3 darts thrown in these places were neither accurate nor precise. And then in the third case here, in this case, all of the darts are within the little 19 there, so what that means is that we're precise, but we're not accurate. We didn't hit the mark, but our measurements were close to each other. The typical way you might see this on a test, particularly on the EOC, is in lab examples. So we're going to say in the lab, students are trying to weigh a bar of metal. The teacher knows that it's 96.4, so the group A students, they do measurements 84.2 grams, 84.4 grams, and 84.1 grams. So in this particular case, the students in group A are precise, but they're not very accurate. Okay, they're well over about 12 grams off of what it should have been, and when we're talking about a small weight like that, 12 grams is a lot. So they're precise, their measurements are close to each other, but they're not very accurate. Group B students, now you can see these are all over the place. And see, this brings up something pretty interesting. They're obviously not precise or accurate in this case, but what this brings up for us is that if your measurements are precise but not accurate, there's probably some sort of error in the way that you've done it. Like maybe these students weren't weighing part of what they should have weighed. They all got about the same thing, but it wasn't the right thing. And that's fixable. Group B, they're probably in pretty big trouble, neither precise nor accurate. We look at Group C, 96.3, 96.6, 96.5 grams. That's all three darts in the bullseye, all three measurements where you want them to be. Those students are precise and accurate, and that's what we're looking for. And this is just a short little example of me being a little precise and accurate.